Hello beautiful people and welcome. In today's video we are talking about the similarity in right triangles. Now the right triangle similarity theorem says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So what ends up happening is you start with one triangle, you draw an altitude from the hypotenuse, and you end up having a total of three. One on the left, one on the right, and the original. Now, all three triangles are similar to each other, so we have similarity statements. So, triangle ABC is similar to triangle ADB, which is similar to triangle B, D, and C. So how would that look like? Well, we have our original ABC. Here's A, here's B, here's C, here's your right angle. And that's similar to ADB, and that's similar to B, D, and C, like that. With triangle similarity, we have something that's called the triangle geometric mean. Now, it's just called geometric mean. I threw in the triangle on it because we're talking about triangles, but the geometric mean of two positive numbers is an x such that a proportion gets formed. Now, when I originally read this, I was like, what is it talking about? So let's go ahead and translate this. So a geometric mean is when you have two numbers and you can set a proportion where an x is created that's the same, and you can basically solve for it. That's called geometric mean. So with this proportion, we have two statements. We can either say x squared when we cross multiply, x times x, a times b. So x squared is equal to ab, but if we go one step further, we can take the square root of both sides and say that the geometric mean of two numbers is x equals the square root of ab. So how does this look like? So let's go ahead and practice. Let's actually flip this paper around so it's not too distracting. And we'll get to the altitude theorem in a minute. But let's find the geometric mean of 6 and 30. So when you find the geometric mean of 6 and 30, it's going to look something like this. Now you can set up the proportion of 6 over x is equal to x over 30, or you can skip that and immediately go to x is equal to the square root of 6 times 30. And we can do that because of the cross multiplication. So 6 times 30, that is 180. Excuse me. And then we do need to simplify that a little bit more. 180 divided by, I believe it's 36. Let's check. Yeah. So we can split this up into 36 times 5. 36 is just 6. So we have x is equal to 6 root 5. Remember, in this unit, we're not doing decimals. We are doing radicals and making sure we have our radicals simplified. That is a prerequisite that we had from semester 1. Okay, so now we talked about geometric mean, and we have this proportion that can be set up. We have two different ones. We have a geometric mean that's an altitude theorem, and we have a geometric mean that's leg theorem. So let's start with the altitude. The geometric mean, the altitude theorem, is that the length of the altitude is the geometric mean of the lengths of the two segments. So we can set up this equation. I'll highlight it for you. And what this is that we have, let's go ahead and separates that. We have one triangle. Okay, we have one triangle. BD is the altitude. So we have the altitude squared is equal to AD times DC. So the best way that I can describe it is I'm going to call this hypotenuse chunk 1 and hypotenuse chunk 2. I'm chuckling over here because that's definitely not mathematical terminology, but it's the little pieces of the hypotenuse that create the entire hypotenuse. So again, hippo, chunk 1, you can call it piece if the word chunk is not your thing. So again, so the geometric mean, the altitude, specifically the altitude theorem, says the altitude squared is equal to the two pieces of the hypotenuse multiplied together. Now, this is not the Pythagorean theorem. We're not squaring anything other than the altitude. What we want to find is the altitude. That is what's being squared. The hypotenuse chunk number 1, the little piece here, and this little piece just get multiplied. You're not squaring it. So let's go ahead and do an example. Find the values of x and y. We have a triangle here, and we know this is an altitude because we have this little section here, and there should be a right triangle here. It got erased. You can see that I had to do some whiteout on this example, but that's okay. We all live and learn. All right, let's go ahead and set up the equation. We want the altitude squared is equal to the hypotenuse, chunk 1, times the hypotenuse, chunk 2. Now let's actually do this mathematically with our lettering. Let's call this A, B, C, and have to switch to Sharpie here, D. The altitude is AD. The first little chunk is BD times the larger chunk, which is DC. So AD, our altitude, is 21 squared. The little chunk is Y. The larger chunk is 30. And so now we have set up an equation to solve for our Y. So we have 21. I'll cover this up so you guys can see my calculator. 21 squared is 441 is equal to Y times 30 divided by 30. And that is 14.7. Now, I did just a few moments ago, I feel like I'm contradicting myself. So a few moments ago, I did mention that we have to have radicals. Please read the instructions. If the directions are saying leave your answer in a decimal, please leave your answer in a decimal. So for example, this one here did ask us for a decimal answer. So now we do have this $14.7. Hesitated there for a second to see what they wanted. They wanted an x as well. So they want a total. So this total, our y is 14.7. So we have x is equal to 14.7 plus 30, which gives us 44.7. Like that. Again, so geometric altitude, okay, geometric mean of the altitude theorem. We got our altitude squared equals, so the altitude squared equals the two pieces of the hypotenuse multiplied together. The altitude squared is equal to the two pieces of the hypotenuse multiplied together. Let's do another example. Okay, we have an altitude. Here you have our hypotenuse. We have our chunk 1. We have our chunk 2. So we have our altitude squared is equal to chunk 1 times chunk 2. So we have 18 squared divide by 15. 21.6. Again, please read the instructions. If they're asking you to leave your answer in a decimal, which this one is, then we keep it as a decimal. All right, now the secondary geometric mean theorem. This is your leg theorem. The length of a leg of a triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Now, what does that even mean? So there's two different things that can be created from this theorem. So AB is the leg and AD is the chunk of the hypotenuse. So I'm going to draw this out as two different things. I just want to show you. Here's A, here's B, here's C, here's D. And we're going to do this one first. So AB squared. This is the leg that we're going to have. So I'm going to write leg squared here. That is equal to AD, so the attached hypotenuse section been calling it a chunk, so we'll stay it as a chunk, times the entire hypotenuse. Okay, again, so the leg theorem. The leg squared is equal to the attached hypotenuse chunk times the entire hypotenuse. Now let's do it again. Draw this one out. Here's A, here's B, here's C, here's D. Now if we're doing this leg here, so that's the leg that's going to be squared. Remember, we want the attached hypotenuse chunk times the entire hypotenuse. Leg squared is equal to the attached hypotenuse chunk times the entire hypotenuse chunk. Okay, let's do an example. We got 2 examples, and then that will be it for our video for today. First, we want to label what do we have and what do we need. I see an altitude right here. I don't have that, right? It's Y. I see a leg here, that's Z. And I see here 27. So the first thing you want to do is look at what you have. What can you do? So I have a leg, and that's my leg that's going to be squared. That means that I need a hypotenuse chunk that's touching the leg that I'm squaring. So this section of 24. Then I also need the entire hypotenuse. Now, I don't know what this section, this little piece is, so I can't tell you what the whole hypotenuse is, but it is x, so let's set up an equation. We have our leg squared is equal to the attached hypotenuse chunk, again, very mathematical, I say that sarcastically, times the entire hypotenuse. So how would that look like? Let's give it some letters, A, B, C, D. We got A, B, C, and D. So our leg is AC. Our attached hypotenuse chunk is DC. And our entire hypotenuse is BC. So we have 27 squared is equal to the attached is 24. The entire was x. So we got 27 squared divide by 24. And we got x is equal to, once again, it is a decimal, and on these, it is asking for a decimal. So we have 30.4. So that means this right here is 30.4. Now I have two things to solve for. We do need to solve for an altitude, and then we do also need to solve for z. Now if we do our triangle, redo our triangle, here's your 90-degree angle, here's z, here's 27, here's 30.4. We can use the Pythagorean theorem to solve for our z value if you want. Now you can also do the leg theorem. Now that we have 30.4, BD is 6.4. And you can do this right here. If you want to do the Pythagorean theorem on this one, you can to solve it, since we do technically have a right angle. So we have, careful with your C. So we have z squared plus 27 squared equals 30.4 squared. I'm going to subtract 27 squared both sides. We got 30.4 squared minus 27 squared. And again, these are going to be a little bit on the ickier side for our numbers. And we got z is equal to about 14. It ended up being, for me, 13.969. So that's about 14. And then we do need our altitude, which is y. And again, you have a choice to make. You can either use the altitude theorem, or you can do the right triangle Pythagorean theorem, because we do, again, see another right triangle here. I'll separate this out for you guys. So we had y, 27, and 24, like that. So we have, again, careful with your c, y squared plus 24 squared is equal to 27 squared. Subtract the 24 squared. 27 squared minus 24 squared, get 153, which again is going to give us an icky number of about 12.4. All right, we got one more example, and then I promise I'll let you go so you can enjoy the rest of your day. All right, what do we have? What do we need? Okay, I see that I have an altitude here, which is 8. I also see that I have chunk of my hypotenuse. And I see, I'm trying to think of what we can do. So we can use the altitude theorem here. So if we look at the altitude theorem, the altitude says that we have the altitude, little chunk, and then the bigger chunk of the hypotenuse. So let's use the altitude theorem. So altitude is 8, little piece and big piece of the hypotenuse. So again, altitude squared is equal to the hippo chunk times the hippo chunk number 2. This is 1 and this is 2. Okay, so we got 64 is equal to x times 20 divided by 20. X is equal to, again, icky number. These all will give you decimals, and that's okay. I get 3.2 as our x. Okay, let's use our leg theorem here. Now that we have things, that means our entire hypotenuse is 23.2. I'm going to separate this out. We got leg squared is equal to the attached hippo chunk times the entire hypotenuse. Okay, so which leg are we doing? We can do z, we can do y. Let's do y first. So the attached, if we're doing y as our leg, that means the attached hypotenuse chunk is 20. And the entire is 23.2. So that means y squared is equal to 20 times 23.2. We get 464. Take the square root. And again, decimals, it's going to be approximately 21.5-ish for y. We can do the leg theorem one more time for z. Now again, beautiful people, with my attached hypotenuse chunks and all these words that I'm providing for you, I'm just trying to get you to help you understand these theorems a little bit more. Obviously, the hippo chunk is not a mathematical terminology. All right, so now we're doing this leg. So that means we have z squared. The attached hypotenuse chunk is 3.2, and the entire hypotenuse is 23.2. So we have 3.2 times 23.2. It gives me 74.24. Again, not the prettiest. Expect decimals because the worksheet that we are working on right now is all asking for rounding. And we got 8.6. All right, beautiful people, that is it for this video. Thank you so much for watching, and I will see you in the next time. Bye.